Hi everybody, this is MoQuant, and today I'm going to be showing you how to program a trinomial tree, compute the implied volatility off of it, and calculate all the Greeks. So let's get started. So I'm going to define a vector, a double vector, which is going to hold the tree, and I'm going to call it box int n for the number of rows, and int m for the number of columns. So now I'm going to declare a double vector, call it res, and then declare a single vector, call it temp. Now come down here, and I'm going to do for int I equals 0, I is less than n, plus plus I, for, no, at first it's going to be temp.clear, for int j equals 0, j is less than m, plus plus j. So temp.pushback 0. So we're going to initialize everything with 0. Then down here we do res.pushback 0. No, pushback temp. And then here we return temp. Res. Okay, so I'm going to comment here builds the double vector which holds the tree. So the next function I'm going to make is a print function, prints out the tree. So I'll call it void print m. So for auto and t x, wait, I forgot that, get rid of that. For auto u in t, c out u, tab, and then end line. Okay, so we've got those programmed in. Let me program the main function now. So int main return 0, and I'm going to input just some sample variables into it. So I'll do print m of box of 3 by 2. Now I'm going to come here and open my terminal. This is a, let me drag that down, reset that. So the way to compile it is g++ tree.c. I'm going to give it a custom one, /o tree.cpp std equals c++ 11, because we're using vectors, so we have to make sure we call c++ 11. And now I do ./tree, and what do you know? It prints me out a 3 by 2 double vector. So okay, so we've got that. So now let me start to code in some of the formulas. The first one I'm going to do is going to be the up factor, which takes in the argument volatility, delta time. Yeah, just volatility and delta time. So that would return exp to the volume times square root of delta 2.0 times delta t. Now the next function is going to be the down factor. So that's just going to take a function of the up factor, return 1.0 divided by u. I should call it up since I already called it u here. And then the third factor is just a 1, but I'll still declare like a function on it. So double m. Wait, did I use m already? Let me change this to o. Okay, now double m. Okay, so return 1.0. Okay, so let's test these out real quick. I'll do double V equals 0.2 and dt equals 0.1. Now I'm going to do C out up of V and dt. So that'll be, compile this, backslash tree. Okay, so this is the up probability. Well, not probability, the factor that the stock price goes up in each node. And then I'll do the down one, which takes the up as an argument. So let me compile it again. Okay, so this is the probability that it goes down. So okay, I got that covered. Now I want to, oh yeah, I have to code in the probability functions for discounting. So that'll be let me just add some comments here. No price change factor, down price change factor, and up price change factor. Okay, so now the next step is to upper probability. So this is going to be double up, and it takes the arguments of the risk-free rate, dividend yield, delta T, and volatility. And so I'm gonna call this A equals exp r minus q times delta T divided by 2.0, and B equals e to the power of negative volatility times square root of delta T divided by 2.0, and the final one, which is e to the power of volatility times square root of delta T divided by 2.0, and then we return A minus B, or no, the power of A minus B divided by C minus B, and square that. So yeah, that's the up probability. Now we can do the down probability, which is just the up one rearranged. So I'm just going to go ahead and copy and paste this here. I'll call this down, and it's actually going to be C minus A. Yeah, C minus A divided by C minus B. Okay, so that's a down probability. And the no change probability is computed as follows. So I'll call this Mo, my own name. So it'll take the argument of up. No. I'll do U and double D, and it returns 1.0 minus U plus D. Okay. So let's declare some random variables. So double R equals 0.05, double Q equals 0.01, double V equals 0.2, and double DT equals 3.0 divided by 12.0. And now I'm going to print out, so C out down. I'm going to start with down. R, Q, V, DT. And then the up one, Q, V, DT. Okay, so compile that. Okay, yeah, so these are the probabilities printing out. And I guess I'll just keep it as it is right now. I think it's doing well. Let me just double check that. Yeah, this minus that. C minus B. Okay, everything's good to go. So now what I'm gonna do is I'm gonna call the actual price function. So calculates option price with trinomial tree. So that'll be double price, double stock price, strike price, risk-free rate, dividend yield, volatility, time, int nodes, and string op type. Okay, so first we're going to define the row and column values. So that would be int row equals 4 times nodes plus 2. Int col equals nodes plus 1. And now we're going to declare the tree. Equals box of row and column. Now let's go ahead and we're going to return some random double for now. But let's go ahead and do print m of tree. And before we do that, let's declare some variables now. So double stock price equals 100, double strike price equals 95. I'm going to do a put option first. Double R equals 0.05, double Q equals 0.01, double V equals 0.2, double T equals 30.0 divided by 365.0, because it has to be in that time format. And then int nodes is going to be 6, and option type is going to be put. And now what we could do is oh wait, we should also calculate dt variable here. So I'll just do that here. Double dt equals t divided by double nodes, just to avoid confusion. And then so I'll go ahead and call the price function here, price of stock, strike, risk-free. And what I'm going to do is, oh wait, I also have to calculate the center. So int split equals row divided by 2 minus 1. So it's going to be in, I'll initialize the tree as split 0 equals stock price. So now, let me just recompile it. Oh, right, it's not supposed to be all caps. Okay, so did it work? Yep, it worked. We got $100 right in there, and then it's the even length, so we can start programming the tree now. So first thing we do is we're going to define a for loop in I equals 1. I is less than column plus I. So the formula for this, it'll be tree tree split minus 2 times I, and then column I equals tree split minus 2 times I minus 1, column I minus 1 times. Oh wait, first let me define all the factors and stuff. So double up equals U of V and dt. Double down equals D of up, I believe. Yeah. So, and then the middle one is just 1.0. I'll call it same equals M. Is that what I called it here? Yeah. Okay, so now probabilities double P up equals, what do we call it? Oh yeah, just up RQ V dt double P down equals down of R. Oh, we can't do okay, let me just rename these. Down function issues. I'll just call that big M. Now we can get back to this Q V dt and double P same equals oh yeah, mo P up P down. Okay, so we got these set. So now, yeah, let's get back to the tree. So it's subtracting, so this is going to be up. And now let's rerun the tree. Let me just compile it. What's that error? Oh, it's not lowercase up, it's capital up. Okay. This program video is going to have some errors in it. Like, okay, so the stock prices all got simulated to the up. What I'm going to do actually is, let me delete this terminal. Let me move this way. I'm going to get a new terminal here, just so like I don't cut off the camera and stuff like okay, CD desktop tree. Yep, we're in the right directory. So now I'm gonna do G++. I'm just gonna do the regular ones. So rmrf tree. So now G++ tree.cpp std equals C++11. Reprint it out. Perfect. So we've got all these working. And then now let's do the down one. So that would be tree split plus 2 times I equals tree split minus 2 times, no, plus 2 times I minus 1 times down. And let's do the center one. So tree split I equals tree split I minus 1 times M. So let's see what this looks like. Actually, let me write a little shell script for this. So it'll be bin bash, and then that would be G++ tree.cpp std equals C++11, and then exit 0. I'll call it g.sh. Let me grant it some permissions right now. Reset that. Compile. Okay, so now this tree is being built better. So what I'm going to do now is I'm going to create a for loop outside of the for loop, and it's going to be for int j equals 0. J is less than column plus j. So it'll be let's see. I believe it'll be call minus j, j plus I, j plus I, and j plus I, and j plus I again, j plus I, j plus I. Okay, so let's see how this performs. So we'll compile it again, reset it. Oh, Oh, perfect. I think it got the full trinomial tree. So let me go ahead and okay, so we got that. So calculate parameters, or call it measures, declare tree, calculate d delta time and factors, set initial stock price, forward propagation. Okay, so now we have to compute the payoffs. So I believe we're using a put option in this. So what we'll have to do is we'll have to discount it using the strike minus the stock price. So in order to do that, I'm going to come here and do for int I equals 1. I is less than row plus I. So it'll be tree I. Yeah, that'll start at 1. Oh, first I have to add the mod. So if I mod 2 is not equal to 0, it'll be tree I call minus 1, because we're going to do this. We have to calculate the payoffs at the last column and then discount backwards from that. And then equals f max, which is the max function of. Oh wait, first also let me add in if op type equals call, else it equals put. So the max will be the tree of I call minus 1 minus the strike price, and the maximum of that, or 0. And for the put option, it'll be tree I call minus 1 equals f max tree. Oh, this is actually supposed to be tree I minus 1. So it'll be I minus 1 call minus 1. But this time it'll be the strike minus the stock price and 0.0. Okay, so let's compute the payoffs now. Let me just recompile it, reset it, a.out it. Okay, so the payoffs worked. They're all zeros because they're negative numbers, and we don't want any negative numbers in here because it'll mess up the full calculation. So yeah, we got these done. Now it's time to discount. Discount to compute option price. So now we want to go from here all the way backwards. So we're going to start off by, and we're starting on the third element. So the fourth element, I mean, so the index of that is going to equal 3. So I'll call it int f equals 3. And now for int I equals column minus 2, I is greater than or equal to 0 plus I. No, minus I, I mean. Okay, so now that we have that, we need to define the second loop. The second loop, to like loop through all the prices. So that'll be for int j equals f. J is less than row minus f. Or no, I think it's less than or equal to row minus f. And then plus j. So the tree row is going to be j, and then the column is going to be I. So yeah, tree ji equals, let me just make sure this works. I'm going to include a negative 1 point, I'm just going to make it negative 1.3, just to make sure the tree works. So that'll be yeah, compile it. Okay, it did not turn out how I wanted it to be. Oh, maybe yeah, F is I think supposed to be incremented by 2. So let me reset that. And also, okay, there's so it formed in the linear formation, but let's see. Because everything here turned into a 1.3, so oh, I think I have to do the same thing if j mod 2 is not equal to 0. Let's see if this works. Okay, yeah, I think it worked. So now what we got to do is I'll come up here to find the discount factor. So double E equals exp to the power of negative r times dt, I believe. Just checking my notes right now. Yeah, I think that's right. Yeah. So now close that off. Discount factor. So we need to compute. We need to define some other doubles. So I'll call it A, B, and C. So A is going to equal this top price up here, and in order to get to that, it would be tree of J. So it starts off here. So it goes -1, -2, -3. So tree J -3. Call and column I +1. B is going to be tree of J. Is it -3 or -2? -1, -2, minus. Oh, it's -2. And then this is going to be no tree J I +1, and third one is going to be tree J +2 I +1. Okay, so now the final calculation is going to be the F max of E times parentheses A times P up plus B times P same plus C times P down. So add a comma to that, and we need to get like the oh yeah, it needs to be for a call or a put. So if op type equals call, else put. So we're at this moment in the first point, and it needs to calculate the payoff of one before it. So that would be tree of J -1, the same column I minus K for the strike price. Okay. And then the bottom one would be tree J of I equals F max. Same equation, but this time it would be tree, no, it would be K minus tree j minus 1 I. Okay, so I think what do I call the show? Okay, so g.sh reset a.out. Okay, so we got an options price, but we now need to check it to make sure it's valid. So this is our put option, and okay, check that. Let me just make sure these calculations are right. So it'd be like here. So j minus 1. Yeah, that's the row, and then the same column. Yeah, I think we're right, but let's take a look. Let's like make sure our option price is like fully accurate. So I'm gonna Trinomial tree calculator, and then these are some really good ones. Let's scroll down to Trinomial tree. Okay, so our inputs. So our strike price is $95. Our underlying asset price is $100. Days to expiration is 30 days. Our dividend yield is 1%. And our option type's a put. And we use 6 nodes. Volatility is 20%. And the interest rate is 5%. And this is a dividend yield, so there's no exercise. So we'll hit calculate. So we got 0.535, and yep, that's exactly what we got, because this is rounded to 3 decimal places, but as you can see here, it's like 0.5347, so that rounds to 0.535. And just to like be safe, let's check it on a call option as well. So 105, same parameters, but this time it's just going to be called call. And then let me change, so the strike price is 105. Same underlying and everything. This is a call option. So let's recompile this. Reset a.out. So it's supposed to be 73 cents. So I calculate that. Yep, 0.738. Yep, that's exactly what we got. So the trinomial tree is correct. So we could exit out of this. Now, let's get into computing implied volatility. So that will be, so we get rid of this. So, oh wait, I'm just going to comment this out. Actually, let me return the option price too. So that would be tree split plus 1, column 0. Okay, so we got the price. Let me just make sure the price works. I'm going to take out the tree portion of it. So STCL price. Okay, so the price returns. Now let's compute the implied volatility and then the Greeks, and then we'll be done. So I'm going to call it implied vol calculation. So for this, we need to define a variable called diff equals 0, vega equals 0, and option price equals $2.50. And then we need to define volatility 0, which equals 0.1, volatility 1, which equals 0.99, and delta volatility, which equals 0.01. And then we come here and we do while true. So diff equals price of stock price, strike, risk, dividend, volatility, time, nodes, and op type minus option price, and our vega equals price. Oh no, I need to input V0 into this, not V. So V0, and then this is going to be V0 plus dV, time, nodes, op type. So now we want to subtract that, so it'll be minus price of stock strike, V0 minus dV, T nodes and op type divided by 2.0 times dV. So now we'll come up here and we'll do V1 equals V0 minus diff divided by vega, and if absolute value of V1 minus V0 is less than 10 to the negative fourth, we'll break the loop. And then down here we do V0 equals V1. So now let me so option price, which is going to be option price, and then see out implied vol is going to be V1, and we'll call this check price, which is going to be price, stock, strike, risk-free, dividend, volatility, but this time we're putting V1, time, nodes, and op type. Okay, so let's run this. Yep, the implied volatility is correct, and if you plug it back into the options trinomial tree, it returns you the same amount as the option price. So we've got that done. Now, I'm going to, now we can calculate the Greeks. So, calculate Greeks. So I'm going to define delta, gamma, theta, vega, and rho. And I'm also going to define ds equals 0.01 times stock price. Same for gamma. Theta is just going to be dt equals 1.0 divided by 365 days. And d vega is going to be 0.01. And d rho is going to also be 0.01. Now we'll do the delta first. So it's going to be delta equals price. I see my battery's running out here. It's going to be price of stock. I have V defined, so we're just going to use V. And I forgot. This is supposed to be incremented with ds. And now subtract that from price s minus ds, and everything else the same. Divided by 2.0 times ds. So our gamma is going to be a little different. It's going to be over here. This is s minus ds. So the parentheses close it off, so that'll be the power of ds squared. So now our theta equals price s. Okay. Oh wait, t plus dt minus price of stock. Oh no, we don't take out from time. Divided by dt. We already computed our Vega above, so I guess I'll just go ahead and copy and paste it. It's just gonna be and we don't need to actually declare Vega in here. That would give us an error. But instead of V0, we'll just do V plus and minus dV. And yeah, it's correct in there. Oh, I already yeah, I already declared a dV also. Oh no, this is big dV. So yeah, we'll just do big dV, big dV, big dV. And then our last one, which is rho, is just going to be price stock strike R plus dr q v t nodes op type minus price of R minus dr q v t nodes op type divided by 2.0 times dr. Okay, so now I can print these all out. So let me just add a line between them. And actually, let me just add a little next line command into this. And then std cout delta gamma and add an extra end line. Okay, so let's compile this. Okay, so we got all of our Greeks. There's a little error. What was the maturity that I used? 30 out of 365. So dt is here, 1 out of 365. Oh, right. Delta is supposed to be negative because it's time decay. So delta's negative. Not delta, I mean theta. So Vega, no, gamma is good. I think Vega is, yeah, it's divided equal by 100. And I believe rho is 2. Gamma came out as 0 for some reason. I don't think that's correct. Um, Let me just rerun this. hang on. Let me look up the gamma formula again. I'm going to show you all the paper that I used. So it's this one. Just keep going down. So the formula is correct, but let me increase the nodes to 16. Okay, yeah, we just needed more nodes in it because I guess 6 is just too little. But yeah. Well, there you have it. We computed the options price tree, we calculated the implied volatility, and we calculated the Greeks. I thank y'all for watching my video. I know this is a long one, but yeah, I mean, I just had to show y'all this is how you do all this. But yeah, thank you for watching my videos. Peace out.